7.4, techniques for solving logarithmic equations. So we're going to take all of our logarithm rules we've been learning throughout the unit and applying them towards solving some logarithmic equations that contain logarithms. And I'm going to do this just by going through some examples and talking about some techniques that can be applied in solving the logarithmic equations. So let's look at this first one here. 1 minus 2 log times of whose argument m-8 equals 0. Okay, so the goal is to isolate for the unknown variable, m in this case. And one of the strategies we've used in the past is, hey, let's isolate for the logarithm, right? Bring the logarithm to one side, separate it from the other constants or other terms, and see what you could do there, okay? So that's what we're going to do first. We're going to leave 1 on the left side of this equation, okay, and bring the other side, 2 log m minus 8. So 2 log m minus 8. Okay. Now there's a couple of ways you could go about doing this. One would be correct and the other one would not be entirely correct. So one approach you might be instinctively going to do is, I want to isolate for the log, and you divide both sides by 2 and you'd end up saying 1 over 2 equals log m minus 8. And yeah, you could take that approach, but let me show you what happens if you do. If you apply that approach and you go, okay, well, let's see. We now isolated the log on the right side, and log naturally has this base 10 here. So you would say, okay, this in exponential form can be written as 10 to the power of 1/2 equals m minus 8. Okay, and 10 to the power of 1/2 is just the square root of 10, and that would equal to m minus 8, and therefore m equals 8 plus the square root of 10. Okay, so this method gives you this solution, okay, but it's not completely identifying another solution that might be valid, okay? So you might have to remember, hey, when you do the square root of something, you have two possible answers, right? Plus or minus. So we should be having a plus or minus root 10. But and that might not be completely apparent to you, okay? But it will be apparent if you follow a different approach for solving a logarithmic equation. So I'm just going to take this second line here that we have. I'm going to duplicate that. Let's move that over here. Okay, and I'm going to show you kind of a different way of doing this. And that way it looks like this, right? I'm going to take, let's just kind of divide our page here. Okay. I'm going to take the 1 equals 2 log m minus 8 and go, I'm going to write it like this. I'm going to say 1 equals, and I'm going to use the reverse power rule to say log of m minus 8 squared. So bring that 2 back up to the exponent. Okay. And now if I write this in exponential form, this says 10 to the power of 1 equals m minus 8 squared. Okay, and if I expand the m minus 8 squared, I'll have here 10 on the left side, and I'll have m squared minus 16m plus 64. A quadratic. Okay, and when you're solving a quadratic, you can get two solutions. And so let's just make this equation set its equal to 0. So I'm going to have to bring the 10 over to the right side, and I'll have m squared minus 16m plus 54. Okay. Now, if you apply your quadratic formula to solve for m, and you'll get your two solutions. M equals 8 plus or minus the square root of 10. Okay, so we've got to this point. Now, there's a couple of things to consider. Also, once you get to this point, your solution, 8 plus or minus the square root of 10, check, do these solutions work, right? So let's check the first one. If I check the first one, I'm going to substitute 1 minus 2 log, and substitute for m. I'm going to replace that with 8 plus the square root of 10, and then minus 8 equal to 0. Okay, and that looks like the 8's cancel, and so we have 1 minus 2 log the square root of 10 equal to 0. And the square root of 10 is just 10 to the power of 1/2, right? And then if I bring that reverse power rule into play, then the 10 to the 1/2, which is then squared, ends up being, let's look at it like this. It's 1 minus log of 10 to the power of 1/2 squared. And in the 1/2 and the squared sort of cancel out and give you a 1, right? So you get pretty much 1 minus the log of 10. And with your logarithm being base 10, that's just equal to 1, right? So 1 minus 1 equals 0. So that's fine, okay? But what about the other solution, right? 1 minus 2 log, and instead for m, we're going to replace that with 8 minus root 10, and then you have a minus 8 equal to 0. Okay, well, what happens here is that you have 1 minus 2, the 8's cancel, but you're left with a negative root 10. Okay, and there you have a invalid solution, okay? You cannot have that log of a negative number. So what you have here is an extraneous root. So, although we went through the trouble of getting that second solution, 8 minus root 10, it turns out to be an extraneous root. But it is still part of the work in solving equations. You have to find that other possible solution, and it may be valid or it may not be valid. Okay, so let's look at our next example, 1b. So 1b is the log of base 2 of x minus 5 plus the log of base 2 of x minus 2 equal to 2. Okay, so now here's an equation. And so again, the next thing we can employ in our techniques for solving logarithmic equations is to try and get all of your logs simplified to just one log term. And here I can apply, if you notice I have a plus sign in between of these two logs, I can apply the product rule for logarithms, or the product law of logs, which is what we learned in our last lesson. So you can combine these two logarithms into one and say here log base 2 of x minus 5 times x minus 2 equals to 2. Okay, and well, if I put this in exponential form, this says my argument, x minus 5 times x minus 2 is equal to, well, if I'm using base 2, it would be 2 to the power of the right-hand side 2. And now I just have a quadratic equation that we can solve. Okay, and so if I expand these two binomials, we'll have here x squared minus 10x plus 10, sorry, x squared minus 7x plus 10, and if I bring the 2 squared over to the left side, it'll be minus 4 equal to 0. And if I kind of simplify that here, we'll have x squared minus 7x plus 6 equal to 0, and that can be factored x minus 6, x minus 1. Okay, so we have a very nice clean solution here, and our two possible answers are x equals 6 and x equals 1. Now I say possible solutions because you should check to make sure that they are valid answers. You want to check that they fall into the domain of your logarithms. So we're going to go back to the original and use the original. Okay, so log of x minus 5 plus log of x minus 2 equal to 2. So I'm going to say here, use the original question, because sometimes when you're simplifying the equation, you might lose some information along the way. Okay, so if I tried x equals 6, what do we get? Well, we get the log of 6 minus 5 and the log of 6 minus 2, both of which are positive, right? So you get a positive and a positive, and so you get some valid solutions. So all logs are positive here. Okay, and I mean, you don't have to evaluate them. You could, but just to check the left side equals the right side. So we have the log of base 2 of 1 plus the log of base 2 of 6 minus 2 is 4. Equals 2. And so this first one is 0, and then the second logarithm here is 2, and that's equal to 2, and I add them together. So we're okay there. Now, if I try the other solution, x equals 1, here we encounter an issue, right? So we're going to have 1 minus 5 plus log of 1 minus 2, and both of these logarithms have negative arguments. So when you have a negative argument, you can't evaluate that. No, 2 to the power, whatever number, cannot be a negative number. So we have an extraneous root here. Okay. Let's look at another example, 1c. So 1c is log of x plus 3 equal to log of 10x cubed. Let me just double check the notes. Your log of x plus, log of x plus 3. Yeah, be careful. Okay, there's no bracket. That's why brackets are important, because you got to know what belongs to the argument of log. So log of x and then a plus 3. Okay, so now we have it's an equation with 3 terms. The strategy again we're going to follow is let's bring the logs to one side. So let's go 3 on the left, and then we're going to go log of 10x cubed minus log of x. Okay, and that allows me to combine them using the quotient rule, right? 2 logs being subtracted, both logs of the same base. I can apply the quotient rule, 10x cubed, the first log there on the top, and x on the bottom. Now we introduce this restriction where x cannot be 0. Okay, so keep that in mind in case it becomes part of our solution. And now we can simplify the argument, right? So log of 10x cubed over x would just become 10x squared. Okay, but even though it simplifies, you still have that restriction, x cannot be 0. Okay, now remember your log is base 10, right? So that's going to be important, because if I were to write this in exponential form, we're saying here 10 to the power of 3 is equal to what's inside of our argument, right? 10x squared. And then I can simplify this, right? So I can divide both sides by 10. I'm going to get 10 squared equals x squared. And then, solving for x, 100 equals x squared, or the square root of 100. So you have 2 possible answers here. So x equals plus or minus the square root of 100, or we can say plus or minus 10. Okay, so you check your solutions. So if you do your checking step, right? So if you tried x equals 10, we get log of 10 plus 3 equals log of 10 times 10 squared. Okay, valid. All right, if you tried x equals negative 10, well, now we have a problem, because we have a log of negative 10 plus 3. This part here is invalid. So we have an extraneous root. Okay, so our only solution is x equals 10. Okay, so I'm going to leave 1D as one for you to try, as well as 1E. I'm going to go to question number 2. Question number 2, let's solve a different kind of equation. So we're going to be solving an equation where the logarithms have different bases. So log base 2 of root x plus log base 4 of x equals to 5. Okay, now the strategy I want to show you here is, well, if you have, let's write this down as part of your notes. So 2 different bases for your log means put into a common base. How do I put it into a common base? Well, you're going to apply the change of base formula. And if you recall the change of base formula, it's log of m with base a equals the log of m of base b divided by the log of a with base b. Okay, so let's put everything into base 2. So let's put into base 2. And so if I do that, I'm going to have here log of base 2 of root x. And my log of base 4 of x becomes log of the new base 2 of x divided by log of base 2 of the old base 4. Okay, and that equals to 5 on the right side. Okay, so some simplifications can start happening here. Log of base 2 of 4 is just 2, right? 2 squared is 4. And so now I can write this equation as log base 2 of root x plus 1/2 of log of base 2 of x equals 5. Okay, and now, well, you can start to see maybe a pattern might emerge. I have the square root of x, but I have also this 1/2 here. I can bring this to the exponent using the reverse power law of logarithms, and I can now write this as log base 2 of root x plus log base 2 of root x as well, right? X to the power of 1/2 is just the square root in radical form. And with that, I can combine the two logs with the product rule and express this as log of base 2 of root x times root x. And as we know, when we multiply two radicals with the same radicand, root x times root x, you just get x. Okay, so we can write that here. Log base 2 of x equals 5. And now in exponential form, I can write this as 2 to the power of 5 equals x. And therein lies your solution. X to the power of 5 is 32. And we only have one solution here, and not two. Okay. Now I will, oh, maybe I forgot. I should go back and give you the solutions to 1D and 1E, or just the answers, right? So for 1D, if you are going to check your answer, we have here m equals 100 as your valid solution. And if you're going to check your work as you're doing 1E, or sorry, what is this? 1E, the answer here is no solutions. Okay. What you end up getting is you'll get a quadratic formula out of this when you apply because you have two binomial factors, right? So when you bring the logs to one side and you get a quadratic, and you solve for that quadratic using the quadratic formula, the square root of b squared minus 4ac turns out to be a negative number, a negative 375. So that gives you no valid solutions to this equation. Okay. What is next? I think there's one more example. Let's see. Oh, level number three. Number three, you can try that as well. It's just more of the same, applying the same technique again of solving a quadratic. Okay, so you can try that. There's a valid solution here at x equals 5 plus square root of 389 over 2. When you apply the quadratic formula, I'll do number 4 here with you. So this is a change of base formula application. So calculate log of 5 of base 2, log of 8 of base 5, and log of 10 of base 8. So you have 3 different bases. So just apply a change of base formula. Okay, maybe you can say let's use base 10 perhaps, right? Because we're going to calculate this on a calculator. Okay, now if you have a calculator that can do that can do a different base, then great, you can verify your answer, but show that you can use a change of base formula if this was a test question. Okay, so for the first logarithm, using base 10, I can write this as the log of your argument 5 there divided by the log of the old base, so log of 2. And for the second log here, I'll write this as the log of 8 divided by the log of the old base, log of 5. And for the third one, we have the log of 10 over the log of 8. Okay, and we can do some cancellations, right? Log 8 on the top cancels with log 8 on the bottom. Log 5 and log 5 cancel, and you're left with log 10 over log 2. And log 10 is 1, and 1 over log 2, which just ends up being, give the numerical or decimal answer, which will be 3.3219 approximately. Okay. All right, there we go. That caps off our end of Unit 7, the end of advanced functions, and we'll be moving on to calculus in the new year. All right.